Okay, Assalamu alaikum. Today we have LO 2.06 mechanics. We have point of toppling. Okay, this is toppling. Our aim, our objective is student will be able to determine the point of toppling, also the angle of toppling. Consider a body resting on a slab which is rough enough to prevent slipping. Rough enough to prevent slip. With the situation as shown in the diagram, the weight is mg will produce clockwise moment. To prevent from slipping about the point x. The slope will exert a normal reaction on the body, and this will provide the anti-clockwise moment about x necessary to maintain equilibrium. Then equilibrium is occurred from the moment and the vertical weight of the body. If the angle of the slope step, the situation shown in the diagram on the right could occur, which is slipping. Something like that, it will be occur. The height of the body, the weight of the body now produces an anti-clockwise moment. Anti-clockwise, something like that. This. About x. The normal reaction is not able contract with this anti-clockwise moment. The equilibrium is not mentioned and the body will topple about x. Then this is the point of toppling and this is the point G of center of gravity. When the angle of the slope is such that the weight acts through the point x, notice here this is the point of gravity and this is the point of toppling. They are on the same vertical line. And it's very important to notice that the point of toppling is under the point of center of gravity. Again, point of toppling is under the point of center of gravity. Okay. Here is a body consists of a uniform solid cylinder of mass 6m, m in unit, base radius r, and height 2r, the height of the right circular cylinder. Attached a plane face to the plane face of a uniform solid cone of mass 4. Radius r and base radius also r. This is height and base radius r. Find the position of the center of gravity of the body. What do you think? Where is the center of gravity of the cylinder? Right, it will be on the midpoint between the center of the two bases. Good. What about the center of gravity of the cone? Right, it's about quarter from the base center of the cone. Okay, don't forget. The body is now placed with its plane face in contact with the horizontal table. We will put it in a horizontal table. The surface of the table is rough enough to prevent the body slipping as the table is slowly tilted. Find the angle through which the table has been tilted when the body is on the point of toppling. Then our object today, or our target, our aim, to find the point of toppling and also the point of the angle of toppling. Don't forget. Here is the body. This is the center of the cylinder. This is the center of the cone. And we put O is the origin point, and this is the axis of symmetry of the two figures. To find the center of gravity, we will the weight of the cylinder 6m times g times r from O, and the cone is 4mg times 2r plus quarter r. I have told you before about the point of center of gravity of the body, which is equal the total mass times mgx. Total mass times mgx. Then of over the total mass, very good, equals x. We can write it 6 mgr plus 4 mg times 2r plus 1. This is x1 times m1, x2 times m2 over total mass. Very good, equal x subcenter or x center of mass. Very good, very good, excellent. X bar equal 1.5 r. This is from O. Then where is the center of gravity? It will be here. This is number A. Okay, number B, we put the body on a table, inclined plane. It's about to slipping. As I told you, the center of gravity and the center of a point of toppling, they are on the same vertical line. To find the measure of angle of toppling, it will be theta. As I told, this is right angle and this is right angle. These two angles are vertically opposite angles, are equal in measure. Then the third one equals the third one. Then the center of the measure angle of toppling, which is between the line of symmetry perpendicular to the table and the line of vertical line between the center of gravity and the center or point of toppling. This is the theta, the same angle. Tan theta equal xo over go, opposite over adjacent, it will be 2 over 3. Shift 10, you can find theta. Here is equilibrium of a suspended lamina. Suspended lamina, like mashallah, this is a body which is can hang it from any point. Here is consider that this is a rectangle. What do you think? Which is in the equilibrium position? That figure or that figure? They suspended from A to the ceiling. This is a light string. Tension T. This is a point of hanging. This is a point of hanging. Okay. And this is a lamina. What do you think? Yes. Here is two forces. This is mg and this is the line of tension. This is two forces. This is are not in equilibrium, but in that one they are in equilibrium when the tension and the mg are on the same vertical line. As there is a result moment about the point A, the position shown in the first diagram is not possible position of equilibrium, since there are only two forces acting on the lamina and their line of action are parallel. They can only produce equilibrium if they act along the same line. Hence, equilibrium is only possible if the rectangle hangs so that the center of gravity G lies vertically below the point of action. There, the point of toppling is under the center of gravity, but here the point of hanging is above the center of gravity. We will show in example how to find the measure of angle of toppling. A rectangular lamina ABCD freely suspended by one vertex C. If CD is 15 and BC is 5 and the lamina is uniform lamina, something I told you like mashallah. Find the angle theta between CD and BC. We said that the point of hanging is the point of center of gravity. Do you remember the center of gravity of a rectangle is the point of the intersection of the two diagonals? Very good. Then this is the point of center of gravity, and this is the point of hanging. This is a uniform lamina. Then the measure of angle of equilibrium is theta, which is here, which is opposite over adjacent. It will be 5 over 15. It will to find tan theta equals 18.43 degree. Very good. Then have to remember, in toppling, the point of topple under the center of gravity. If you hang the body, then first of all determine the center of gravity of the figure. After that, the point of hanging and the center of gravity are on the same vertical line. Okay, here is some examples. I will put it on the session on Microsoft Teams with the link, and you can solve it to discuss on the another session, because next session inshallah it will be a quiz. In question from 1 to 7, a body consists of either a uniform solid or two uniform solids stuck together. Here is one uniform solid, cone. Here is a cone. Here is a cone and a cylinder, sphere and a cylinder. Okay, each body is placed upright, a rough horizontal plane which is slowly tilted until the body is about to topple. That's an easy question. Find in each case the angle through which the plane is tilted. Okay. This is the two body. You will put it in inclined plane, and this is maybe the sphere, and this is the cylinder. Okay, and then to find the point of gravity, and this is the point of toppling. Okay, then it will be, this is the angle of toppling, and the same of this angle. You find the point in each case, and here is the radius is right, the height is r, and so on. I put the measurements you needed. Okay, that's an easy one. Please try to do, and to correct yourself, I put the answers at the last page. This is the homework. Okay, this is two cylinders, and this is a sphere, and this is a hemisphere of mass 10, and this is a sphere of mass 16 m, and this is a sphere, and also this is a cone. Here in example our questions, another type of problems. In question 8 to 16, the uniform lamina are freely suspended. In each case, you will suspend it from the point A, and so on. Find the angles that the line AB with the vertical. Each grade consists of units. You can This is 1, 2, 3, 4, 5, 6, 6 on the grade, and here is 4. Here is a body. You will find the center of gravity and center of gravity, and then it will be suspended from the point A. You will find the center of gravity of the whole figure. Here is the same, and so on and so on. Okay. This is a trapezium, and this is also the right trapezium, square, and here's a whole square, circle. You will find this is the center of gravity, and this is the center of gravity. You will find the center of gravity of the whole body, and then find the point of it will be hanging from A, then the same as you find. And here is the answers. Please try to solve them correctly, and you can examine yourself, and this is the results. Please try to do it, and we'll meet again inshallah on the next session on Tuesday. Thank you. Goodbye.